Okay, so the first part of the computer science syllabus, okay, c'était sur un number system. Okay, we have covered some that are quite below in terms of syllabus in the syllabus document. Okay, now we're going to start with hardware and complete all part on hardware, and then we can start with software. Dans le partie de hardware and so on, we have different topics, okay? Von Neumann architecture, fetch, decode, execute cycle, input, output, et tout ça. We'll take this and do everything related to these topics. Okay, when you speak of an architecture is like a plan. Same as a home architecture, okay, or a building architecture. It's the way how things are structured, how things are connected. Okay, alors one of the oldest computer architecture means how the components in the computer are organized. Okay, words described by the von Neumann. Okay, you please follow. I will give you quiz in between. Okay, so I'll send you the notes by the end of this lesson. So please follow and take important notes in between. So what is the von Neumann architecture? When we speak of the von Neumann architecture, we always speak of the program, stored program computer concept. OK? Je m'explique qu'était ça le stored program computer concept. OK? When you look at your program, okay, this is your program. Your program has many instructions. Okay, like here I have divided the instruction into 1, 2, 3, 4 parts. Now, since we multitask nowadays, okay, sometimes you need to watch TikTok or Facebook or Instagram, okay, so you switch in between those apps or programs. But it was not like this during the years of von Neumann architecture. The whole program has to be loaded at once in the memory. Okay, il prend le programme en entier, il garde ça dans la mémoire. Servi par servi, il reste dans la mémoire. Jusqu'à qu'il commence le programme là, incluse. Okay, c'est ça le stored program computer concept. Nowadays, what we have is part of the program in memory. But with von Neumann now, we have the stored program computer concept where the whole program will go in memory and those programs will have instruction and those instructions has to be brought one after another, ça qu'on appelle le sequential manner, for it to be executed. Hence, so without the stored program computer concept, ça deviendra un petit peu difficile pour qui programme capable d'exécuter. Alors, même ce concept-là commence à être servi de manière sur l'architecture. Now, I'm going to give you some of the important features of von Neumann. Okay, look at it very carefully. The first important feature, say the whole program is loaded into memory. Okay, now these are the features. In von Neumann architecture, there is only one single central processing unit, only one processor. Nowadays, we have multiple processors. Okay, and the processor is able to access the memory directly. Processeur là, CPU là, on connaît CPU, c'est petit casier qui rentre le motherboard là. Il gagne l'accès avec mémoire directement, mais au disons, il y a un type de mémoire comme cache qui reste intermédiaire. Okay, you have heard maybe on your mobile phone there's a cache memory. Okay, cache stores instructions that are used frequently. Okay, and instead of going to the main memory, okay, sometimes we can look onto the cache. Mais là, il n'y a pas cache. CPU gagne l'accès direct avec mémoire et le mémoire, quelque part, il store le programme en même temps sur bande data. La mode programme avec sur bande data, un programme, il des fois, besoin beaucoup de calculations. Alors, il y en a beaucoup de calculations, des fois, il a besoin de store bande data, même réponse de mémoire. Okay? Stored programs made up of instructions that could be executed in a sequential order. Tu comprends pas sequential order? L'effet numéro 1, l'effet numéro 2, l'effet numéro 3, et puis l'effet numéro 4. Good for everyone? We look at a quick activity now. Okay, what is the basis of von Neumann architecture? So you have been given many terms here, and like I discussed, von Neumann uses stored program computer concept. Je vous avais dit que le stored program concept, c'est que le programme en entier est stored en mémoire et qu'il est exécuté. Now, which component is essential in the von Neumann architecture? Okay, so the CPU. And which type of memories are used? Okay, here I've told you that we need memories that will store both program as well as data. But we have not mentioned the term RAM and ROM because during those particular years, okay, dans le von Neumann architecture, le mémoire était connu comme le IAS, Immediate Access Store, which we're going to look in a few minutes. So what are stored programs made up of? Okay, in von Neumann architecture, on a random data, sequential order, instruction that could be executed in any order. So here, how they are made up the stored program, okay? So here we wanted to check whether you know you have the sequential order there. Definitely not random data, definitely not images, and not which design is mostly still used is of course the von Neumann architecture. So quite quick in terms of quizzes. Here I've given an idea of how the CPU is structured. Okay. In a few minutes, we're going to do a small quiz on what does the CPU contain, what are the main components of the CPU. Now, if you see here, we have the input device. The input device also forms part of the von Neumann architecture because without the keyboard, without the mouse, the computer will not function. Okay, but components of the CPU, first we have control unit, ALU, qui nous appelle le arithmetic logic unit. You need to know the functions of each of these. Okay, in simple terms, what they do. Registers, and then we have memory unit, which is lost. As you can see, the CPU has direct access to the memory, and those results are sent to the output device. Can you see some of the registers here? Shan. PC, CIE. We have given AC, but AC is not considered a special purpose register. It's considered a general purpose register, which we're going to see in a few minutes, and MAR, and then we have MDR. Now, there's one important component which is missing here, which is the system clock. Nos ordinateurs ont un réveil ou ce système en entier qui synchronise l'information. Un réveil qui fait nous en dans la vie, c'est pour être l'air pour capable de faire un bon travail d'après les temps qui besoin. Computer aussi, il y a un système clock qui contrôle comment l'instruction peut exécuter. The CPU is an electronic circuit responsible for execution of instruction of a computer program. Nous also appelé le microprocesseur ou bien le processeur. But the main function de CPU, c'est de prendre un programme sur une instruction, lui travaille, il exécute. Où ça comprend? Ben, instruction est en forme de langage anglais. OK? Add, load, etc. Pareil que moi, je fais, c'est pas print. Moi, si tu fais en Python en 39. Mais ici, il y a un petit peu comme ça. Ça m'a instruction-là, il est converti en binary parce que le computer comprend ce binary. Alors, ça travail-là, c'est CPU qui fait. OK? Là, il y a maintenant une instruction par le stored program computer comme ça. Mais juste derrière ça, le CPU, il n'est pas fait à tout seul. OK? Il a besoin des trois travailleurs comme ça. Et ça m'a travaillé là, on appelle ça le control unit, etc. Alors, these are the components. First, we have ALU. Second, we have control unit. Then we have system clock. System clock aussi, ils font partie de CPU. Et puis, on a le IAS qui m'appelle le Immediate Access Store. C'est le RAM, le main memory. If you go back to your diagram here, this is a memory unit. Vishan, what were the components I just said? CPU, Vena? Oui, what are those names? Control unit, après Kitchener. Non. Control unit, ça mémorisé là, hein? Ça mémorisé. Tu vas me donner un quiz. System clock, pas system clock, system clock. Immediate access to control unit avec arithmetic logic unit. Ça, chacun fait un petit travail dedans. OK? Le arithmetic logic unit, the name itself tell you arithmetic. That makes a plus, the minus, all calculations needed. And logic is like comparing values, greater, less, pareil, dans selection, dans if statement. OK? Mais tellement de programmes, ça prend une décision et de là, le logique doit apparaître there, carried out, logical operation. OK? Et tout le résultat qui est lié au travail, calculation, etc., il y a un temporary register qui m'appelle accumulator. Accumulator is a temporary register. Why do you call it temporary? Means data that goes there, okay? It won't be there after a few minutes, maybe after a few seconds. Maintenant, control unit, le mot, ça c'est control. Là, il faut coordinate ou bien il faut synchronize tout le data flow qui est là. Tout ça est arrivé, communication entre control unit et ALU memory arrivé à travers une buses qui n'est pas encore décrit là. En ce moment, il faut cause une bus, water buses. OK? Mais le control unit, il y a une instruction depuis memory. OK? Et que l'histoire ça dans programme counter. L'instruction est interprétée et signals are generated along the control bus to tell the other components in the computer what to do. Qui peut faire? Qui peut faire? Et ce main function, c'est synchronisation de data flow. Et je trouve le mot synchronisation, là, il peut creuse, control, unit. Mémorisez parce que ça, les notes, you'll do a print out of it. I hope you're doing a print out of your notes. Otherwise, ça sera complètement banal de vous donner de PowerPoint slide. As from next week, I will start checking whether you're printing the notes. Okay? Alors, this week, if I give a computer architecture, next week I have to check whether you have printed the notes or copied the notes. So as those who are online, you send me a picture. Or you bring the notes here if you're coming. Toury, il reste 5 pas ici, pas terminé son face-to-face. Hein? A system clock is used to produce timing signal on the control bus to ensure this vital synchronization took place. Oui, il y a un flux de l'information. OK? Et que cette flux de l'information est contrôlé par un réveil qui s'appelle le system clock. Alors, when you see timing signal, le signal de timing, là, c'est un system clock qui fait. And then we have the immediate access store. The immediate access store for all the data in your program that the CPU needs to access. Qu'est-ce que c'est dans immediate access store? Parce que si nous stockons dans hard disk, il prend beaucoup de temps, il est lent. Okay? This is why I say this is done because read and write operation carried out using the IS are considerably faster. Okay? Pour y avoir d'informations dans IS, plus vite qu'il y a d'informations dans hard disk. Rappelez bien, et que IS is used to speed up operations. So, disons IS, c'est ce qu'on appelle le primary memory. Maintenant, nous avons register, si vous dites bien, dans le von Neumann architecture. And we're going to study the registers, mais je vais vous expliquer comment le fetch decode execute cycle function in a few minutes. OK, avant ça, comprend le fetch decode execute cycle, and then you can look at other operations that are needed. Let's do a small quiz up till the von Neumann architecture and the components of CPU, etc. Et puis, I'm going to stop the meeting and then take a fresh meeting so that you can follow.